I hope everybody is able to see my screen. Today's session is about what is Elasticsearch. So the domain that we are talking about is full text search. First, let us understand why this full text search is there. When we ask about this Elasticsearch or Solr, whatever it is, people most of the time they confuse this with NoSQL databases. Or whenever I say Elastic, people mention that we use ELK, so we are using, is Elastic and ELK. Elastic is part of ELK. This E is Elastic, but ELK is more than that. It has other solutions also. In general, Elastic as such is a tool that can be used for multiple use cases. So in order to understand that clearly, it is not just these two. So that is first thing. It is not this. That's one thing that we need to understand. Not just NoSQL DB or ELK. Basically, it's called full text search. What is full text search? If you go to any shopping cart or something like that, basically, if you want to search with some text, something like you go to say Flipkart, and then you want to search iPhone. So this iPhone, this is a text that is going to be searched for all the products, right? Into all the products. So that is kind of full text, right? So databases that we do, we have mostly they will search field by field. They are made for that. And apart from that, in your left side that you see, right, these filters. So these are called buckets, aggregation. In order to do these features only, we will use this full text search engines. Let us consider it even in the high level. What your databases are good at, they are good at finding matching results. So you are going to find matching results. This equal to this greater than this lesser than this is in the range. That is matching results. But we move towards not just a matching result, we move towards a relevant results. For example, in an e-commerce search, if you are looking for iPhone, even if the shopper doesn't have iPhone, probably he'll give something like OnePlus. So basically, he understands what you are talking about. He will fetch you the relevant results. And also in iPhone, there are some personalization. If I search iPhone, probably it will give you specific models based on the place that I'm searching from. If I'm searching from India, probably it will show something that is hot in India. So basically, it's more like personalization. So two keywords that you need to remember why we use a search engine from the databases. So there are just two things. One is relevancy, and another one is personalization. So your search, personalizing it. So this personalization. So these are all the things that you will get out of this full text search engine. As a business, we all move towards these kind of search results. It's not just matching, because sometimes what we search, we don't know. Probably we are searching with something like some vague idea. Then these are all the things that can get you to reach there effectively. So it's all about these two areas. We will each of these solutions, these two areas in a different manner, like Solr, Elastic, Research, or something like that. But to be specific, we will see Elasticsearch in detail sometimes. Okay. But if you are coming from a traditional background, to understand what kind of data and what kind of data structure that it gets into this kind of full text search engine. If you remember, traditionally in relational databases, when we had only relational databases some 10 years before, we classify our systems into two categories: OLAP, OLTP. One is called online analytics and processing, I think so. Another one is called online transaction processing. Most of your systems will get into any one of this category. So let us consider a booking website. If you have a booking website and you want to book the tickets, these are all transactions. You need your transactions will have a lot of constraints, foreign key, unique key constraints, and all those stuff. So it's all normalized DBs. Basically, you use for OLTP. If you are coming from a relational database, you will use a normalized DB with all the constraints, everything. And for OLAP, you will use denormalized databases. So on a high level, if you consider these kind of search engines are sophisticated engines to handle your OLAP use cases. So it's kind of going to be denormalized. They are not going to have a lot of constraints and all those stuff. They are just going to be stored. They are going to allow you duplicates also. But the idea is two things. One is the speed of search and how effectively, how many combination that you can do. It will give you the powerful search features. That's the idea. So in Elasticsearch, in Solr, in Research, first let us keep it in mind. The kind of data that we are going to store is kind of this category. Let us not consider this OLTP also. Hope we are going closer to this area. Now, coming to this OLAP or OLTP, what kind of people? Let us segregate them to understand what each people responsibility. If you're coming from a startup, probably everybody will be doing everything, but then clearly segregate these three areas. These three areas need different mindset, different process altogether. So here The first one is infrastructure people, the people who create your whole infrastructure, because you're going to deal with a lot of data, right? Your data should be available, your data should be approachable, your data should be highly performant in terms of retrieval, indexing, and all those stuff. That infrastructure creation is first kind of people. Here you call Elasticsearch administrators. In bigger organization, you'll have Elasticsearch administrators. They will create your clusters, configure your cluster, they'll make it high availability and all those stuff. That's one thing. And then data engineer. Data engineer is more attractive word, but basically what we are talking about is people who get the data into your system, basically indexing part. Indexing your data into your Elasticsearch or Solar or Redis. That's one part. Then comes last part where you actually search your indexes. So the Flipkart example that I showed, that's the last part where you search, filter, and all those stuff. That's the last. So it goes through these three people. We will understand these three people's roles and responsibilities in detail later tomorrow. But for now, let us understand that this is what we are going to do. Till now, any doubts for anybody? Is the scope of what we do is clear?
I'm a little bit confused about this OLAP. Could you just briefly tell me, do we use only for Elasticsearch or what exactly it is?
No. OLAP, okay, thanks Deepan, thanks for the question. So in a typical world, OLAP is just a standard kind of how you structure your OLAP versus OLTP. This is there for quite long time. So if you are writing a system where, for example, if you consider Redbus as one use case, right? Considering about booking modules. In booking module, only one person should be allowed, one ticket should be allowed for one seat. So that's a transaction. And if payment is successful, then only ticket should be distributed. That deals with a lot of transactions, right? Transactions are highly based on contracts. You should not break the contract. You have these atomic features, data consistency, everything. That is typically a transaction processing system. But in OLAP systems, you will basically use them for fast retrieval. If you go to Redbus and then search your buses, search your trips, that is basically OLAP. It's those kind of data. It is created for analytics purpose and then search purpose. That is called that is basically come under a category of OLAP.
Okay. Thanks. It clears my doubt. Thank
you. And then in that case, if you just stick with your databases, what we usually do is in databases, you could put this foreign constraints to avoid duplicate. But if you look at history tables in databases, we will not put any constraint, because history tables, you'll just keep writing it, you'll use it for search only. You'll just keep dumping the data. Because if you put more constraint, what will happen? Your insertion will take time, because it will be checking for the constraint for each of your inserts. But in OLAP, you cannot do that constraints. You just keep dumping the data, and then we'll use it for search. And you will allow duplicates also. For example, okay, in another case, in databases, you have views, right? Where you have databases, but you will have multiple views to have different perspectives. If you are using if you are familiar with materialized view in databases, what you do is you copy the data physically and then create a duplicate for fast retrieval, right? So those kind of systems basically come under this OLAP. You will allow duplicates. There won't be much constraints. It's all designed for fast retrieval and then effective retrieval, effective perspective. That's why we do OLAP. With that, now let us get into, okay, this is the field that we understand. Okay, so where is it being used? There is quite a bit of a job market available for this. That's why people are really getting into this. And there are different use cases. Each use case needs a different skill set, something that we'll see later. But basically, for example, if you are familiar with application monitoring, where all our log information will get into a distributed logging system, basically it will have some time series data. You can search what kind of errors that we had, troubleshoot with the log files, creating alerts. That is where you use tools like Splunk, ELK, and all those stuff. So that internally in ELK level, ELK uses Elastic to store its log data. From there only it retrieves it. That's one area. And apart from that, these kind of enterprise searches like e-commerce websites, or you go to any other enterprises where you want to do a bucketed search, then we will use this. Now coming to Elastic, in this place, what Elasticsearch is doing. Both Elasticsearch as well as Solar, these are all the popular search engines today. They both are based out of a library called Lucene. That's the fundamental library that will do all your search. You will find very little information, surprisingly, about this Lucene, but it's worth. You can go through that. We'll see that in detail. So this is the library that powers Solar as well as Elasticsearch. So what is the difference that Elasticsearch is making is, Now this Lucene is good in indexing your documents locally, and then it can search the documents locally. But in a typical world, you want to scale your database, right? You will have a lot of data, and one single machine will not be enough. You want to horizontally scale your system. So what Elasticsearch will bring in is, Elasticsearch will use Lucene at the heart of the functionality for your all your search. But on top of that, Elasticsearch will give you an infrastructure where it's kind of giving you a distributed file system. If you put the data, it will split the data into multiple nodes, specify each node a specific responsibility from the DevOps side, and then make these data available through a REST API, which means it's easily available for everybody else. That's what it is doing. So Elastic is kind of in simple sense, Lucene taken to a network level scalability and network level standards like REST APIs and all those stuff. That is what Elasticsearch will provide. Now let us get into the official Elasticsearch download. There are multiple ways of downloading using Elasticsearch, but I am going to use a very specific route now, just to make sure we understand what is how it is internally. That's the idea. Now, if you look at this, you can do it with Docker, Kubernetes, and all those stuff. But I am actually going to take it from the direct tar file. For example, Mac has a tar file. I just downloaded the tar file and then unzipped the tar file into this. Now this Elasticsearch that you see, right? This is the download that I had. I just unzipped it. Let us just get into that. What is it? After look into this. Okay, this is the downloads folder. Now let us look at the size of the Elasticsearch folder. So it is 476 MB. That's content. Here Vaibhav can pitch in. We will see that whatever we covered earlier, we will see that now. This size can be drastically reduced. What is this Elasticsearch? Elasticsearch is based on JVM. Let us get into the Elasticsearch folder now. Now let us look at the content. So Elastic is a pre-bundled app. So as Elasticsearch is Java-based application, it has to bundle JDK along with it, and it has JDK with you, and that is taking majority of this 476 MB. Let us see the size of the directories. du-sh 259 MB is taken for Java alone. It's basically JDK, it's not JRE. That's one thing. Now let us start Elasticsearch. I'm going to start Elasticsearch. Let us start Elasticsearch. Now when you start Elasticsearch, just watch out for the log. What is it doing? Before we start Elasticsearch, let us see what is this Elasticsearch is made of. How do we see that? Elastic has this kind of libs, right? So let us list what is the lib that it is based on. So these are all the libraries that Elasticsearch is based on. Surprisingly, I had some other lists. Just today I took the download, and then I'm seeing that many of the dependencies are gone now. Elastic is evolving. But one thing that you can see for sure is Lucene. So it's based on Lucene. So all those Lucene related libraries will be available for you. Apart from that, it has a lot of other, it depends on Jackson for all your JSON processing, Joda for all your timing and all those stuff. This is used for your geospatial queries. That's all the library that it depends on. And apart from that, what we are doing is, okay, let us start the Elasticsearch and see. Okay, I'm starting Elasticsearch. So as I told, Elastic is Java based. So first it has to start the Java. Now you can, if you want to experiment it, you can apply all the modularized JRE. You can build a JRE for Elasticsearch if you want to experiment it to reduce the size. And then you can use kind of class data sharing or whatever you want to do. You can experiment it. But you see, it is starting with OpenJDK server, and then it is starting Elasticsearch. Elasticsearch is a network-aware program. It can form network on its own. If you are coming from traditional databases, if you want to create a cluster MySQL replicas, you will do a lot of manual work. You'll create nodes, give firewall routing and all those stuff. But in modern day databases or modern day systems, they are all network-aware, which means all that you need to do is you just need to make sure that they all come under a single group and they are visible to each other. Elastic can form a cluster by itself. This is something that we will see in detail. But basically now I'm starting with a single node. It started in a single node. That's what it says. Let us look at what Elasticsearch is doing here. Elasticsearch default port is 9200. So here it is. Elasticsearch, when it starts, it creates a name on its own. As it is single node, it will give a cluster name, and then I have a specific node, the current version of Elasticsearch, and then the Lucene version it is based on. That's what it says. Okay, we will just index only one data for today. We will see the rest of the items later. But let us just look at how you index the data. I'm going to load the data. So loading a data is very simple. All that you can do is you can put the data. Say for example, I want to put this employee into Elasticsearch. Now if you look at, this is my Elasticsearch. Now I'm going to put the data. This is all freestyle. Now I'm going to put the data, my employee data inside. So I'm going to create an employee, but employee index is not found. So instead I'm going to create this. Now I'm saying bash load data. How many employees that I want to load? I'll say, okay, 5 employees. So 200. I say load data 5 employees. So it actually just indexes the data. Now let us just see what is the data. So the expectation is employee. Employee, when you go to employee, it just gives you the mapping you just created. So it just Elastic understood that you create something called age, that's of type long. You created something called name, that's of type text. Creates a mapping. So here is the place where it is not a NoSQL DB. It's in between an SQL and NoSQL. Basically, the first time that you create, Elastic detects your type and creates a schema for you. It's not schema free. That you need to keep it in mind. This is going to be really, really useful when you are doing indexing later. Now let us look at the data inside. I'm saying, okay, search. Now these are all the data that you just entered. So on a high level, Elastic will just store your JSON document and retrieve your JSON document. Keep it in that way for today. How effectively we will do search and all those stuff, we will see in detail in introduction of Elasticsearch tomorrow. So far, any doubts?
Satish, I couldn't follow. I mean, how did you enter the data, or you got the sample files already?
No. See, if you look at this specific statement, right? So what I'm doing is I'm just making a curl command with put. I'm calling this URL, passing my content type as this, and this is a JSON that I'm inserting. So basically I put it in a loop. So it just creates Thirumurugan 1, Thirumurugan 2, Thirumurugan 3, Thirumurugan 4, Thirumurugan 5.
Okay. And it directly put into database or in a JSON file separately?
There is no database here. Elasticsearch is not database. It's basically an indexer. Consider that it's a file system. So you keep storing this JSON files inside the system.
Okay, clear. Thank you.
You're just indexing the file. There is no constraint, nothing. It's just a freestyle. For example, now you want to index even more data. Okay, say Manoj, and then you want to give something like extra fields that you want to give. Say, for example, city. Earlier this field was not there. Now if you want to run this again, load the data, Elastic will not complain. You create another 2 employee, it will create it for you. So total you will see, if you look at search again, so you see Manoj here. So it created this one.
So okay. It is somewhere. So is it somewhere in that inside that installation folder of Elasticsearch, data got inserted and the indices got inserted?
Okay, that now let us see where this is getting stored. But before where it gets stored, let us just look one small strange part of it, but that is very important to differentiate Elasticsearch from SQL database and the NoSQL database. Elastic is neither an kind of a schema specific database as well as it is not schemaless database. Now I created age as this number. Let me try to create the third time that I'm trying to create. I'm going to create something like this. And then I say, okay, this is Bala's version. Now I don't have city. Load data, 2 employee. See, it says error. The reason that it says error, okay, because now let us just look at, I'm just looking at the schema that it just created for us. Localhost 9200. I'm just, if you go to just the index directly, it will give you something like your describe table. Okay, that is what I'm trying to do. What is that employee will consist of? So it has created this schema for you. Let us look at the schema. What is this schema? We never specified any schema, but when you insert the data for the first time, Elasticsearch reads your JSON and understand the fields and create specific structure for this. For example, in employee, when you enter the first data, it understood that there is an age and that if the first value that you get for age is a long. So it created that, it understood that it's long, and that is how it is going to operate for the index from now on. But later at some point in time, you are inserting a string value, then it shows error. The reason being, you can't put a string inside a long value. Okay, now let us make it another strange experiment here. Okay, now what I'm going to do is, the problem is some Elasticsearch makes some smart decisions. Earlier, the earlier version of Elasticsearch was very smart, and nowadays it is not that smart. The reason being, it's intentional. When it is making decisions for you, many people are not aware of how the decisions are made, and we are making mistakes. Now Elasticsearch is more strict. It will not do a lot of smart checks. It will do only limited items. Now let us look at the another case. Okay, now in the name, I'm not passing string. I am passing a number. So it should fail, correct? Anybody have difference of opinion? Now I had a string field. Earlier I had a number field. I passed a string. Elasticsearch failed. Now I have a string field, but I'm passing a number. Let us look at what is happening now. I'm just creating one data. Okay, long.
Can you fix the age? Else it will throw error.
See, 3. Good catch. Good catch. Now let us look at name. Also, I'm passing number. Elasticsearch should actually fail, but Elasticsearch did not fail. Let us look at the data. Let us look at the data that it just created. It created the data name equal to 3 because number can be converted to string. That is what Elastic understands. So these kind of smartness and also Elasticsearch will do. You should be aware of that. Where it will throw error, where it will not throw error. You should be aware of it. Consider that it's a plain, simple file system. It will not do everything that your databases are doing. Now coming to this question of where it gets stored. That's a very interesting question because there are two parts. Where it gets stored and how it gets stored, because in a typical world, you are not going to store all the data into single system. Elastic is capable of handling terabyte of data, not because it stores all your terabyte of data into your single system. It stores, it split your data, makes duplicates of the data, that's called shards, replicas, and then it shares across multiple nodes. But to be specific, in a single node environment where it gets stored, let us look at that part now. I'm going to just say Control C. Now, if you look at ls of Elasticsearch folder, you see this directory called data. So that is the place where it stores your data. ls of data. Okay, you want to experiment that. Now let us see rm-rf data. I removed the data. Now I'm starting Elasticsearch again. When you start Elasticsearch, you have not inserted any data yet. The data folder should be empty. That's our expectation. Just starting really slow. Hopefully in Elasticsearch in future versions, they will use modularized JREs, I think so. The size of Elasticsearch is one of the concerns compared to other people. So it created the clusters. Now let us look at the data that we just entered. No, it is not there. I think Elasticsearch is not started yet. Okay, it's still starting. During the starting, there are a lot of activity that Elasticsearch will do. As I told, it's a self-coordinated network system. It will try to find the friends over the network and all those stuff. That's why it is taking some time. But now the site is running, Elasticsearch is running, but the data I entered, employee data, is not available. They answer your question. So it gets stored into a folder called data.
Yeah.
Okay.
Satish, if we add another property, will it update the mappings or it will throw error? So now I have only name and age, right? If I enter salary as well.
Yeah, we just saw that, right? If you add anything, Elasticsearch will add it because for that you have not created any type so far. If there's a new field coming in, and this can be customized. Every bit of Elasticsearch behavior can be customized because search is going to be very different for different use cases. For example, if you an Uber kind of search, where IoT search or application search, the use case itself is different. For example, this specific use case, right? So what is happening behind the screen is Elasticsearch reads your data, understand the type, and then create that. Basically, it is doing auto creation of types, correct? But if you are indexing from a database table, you know your type well in advance, and you don't want Elasticsearch to do this for you, right? In that case, you can say, Elastic, switch off that feature. Don't do it. That you can customize it, but if you don't customize it, whenever you add a new field, Elasticsearch will take it.
So in
there is
general,
one question
in case
on
of,
the data type.
Yes.
How is the other structures getting stored? Like say employee, this is one employee, maybe another, maybe a department structure.
Okay, that's another index. You can either just consider that at the end of the day, everything is a JSON file. In some cases, you will store JSON as in your case, you can store department as another folder, and then you can store, that is called index here. Or otherwise, you can put a nested JSON, right? Something like, say, for example, department. And then you can store your department object here.
Okay.
It's a nested document, embedded document.
Okay. And searching across this nesting is seamless.
Seamless, yes.
Okay, thanks.
In fact, it is preferable. Elasticsearch is not your relational database where you can make join queries and all those stuff. Elasticsearch will give you glimpse of those features, but better not to be used. If you want to get better out of your search systems, make your data as flat as possible. Don't worry about duplicates. Make a duplicate, but make it flat.
So Satish, it is better to use embedding in Elasticsearch compared to any kind of relational reference.
Yeah, but there are cases where you cannot just keep embedding it. For example, 1 to n, m into n. If you have a lot of permutation combination, you cannot do. That needs a separate way of organizing your data. But ideal case is to keep it flat.
Okay. And so in that way, does it follow a bit of the paradigm of data warehousing where data is usually kept as flat? In data warehouses, data is usually kept in a flat format. There's no relationship or much of that.
Yeah, by default, all the indexes are
so
flat.
does it follow a similar?
Yeah,
Okay.
it's just a flat structure, but it gives you certain features to kind of make some join queries and all those stuff. But ultimately, it's like how you design your data model. If you design it in a way that is very specific to your use case, then it's easy to search. That's why I put the 3 items, right? Infrastructure, indexing, and search. You cannot leave out one. The effective way that you create a cluster is easiest way that you index it. The effective way that you index, it's easier to search.
So is there any specific way that I can decide what indexing should be done and what not? See, with every day increasing the data, the chances of increasing the index sizes do increase a lot.
Correct.
So now I say that I got a name, I got age, and I got department. In case of traditional RDBMS systems, I specify my primary key, and based on that, the indexing would be done, and that is limited to that column. But here in this case, looks like every other schema column type is getting indexed. That does indicate that I am storing 3 times of my actual data with indexing data.
You have control over it. You can mention what kind of query that you will execute against a single column, and you can specify to that. There are things called analyzer tokenizers. And you can also say what fields that should not be indexed. Sometimes, for example, SSN numbers, SSN social security number should not be indexed as a standard. So that you can mention in that when you create the index. See, that's what I told you. The index mapping is critical. The index mapping is critical. And the index, for example, data. The index mapping is created, right? See, for example, here, this index mapping, we will not let Elasticsearch to create. Because these types that it creates, right, you can optimize it to a lot of things actually. So that usually the settings, right, you will optimize it according to what you see is just a free state. Many people don't touch this area. They just throw Elasticsearch cluster, start indexing as it is, and then let Elasticsearch create the index. That's not the right approach. You are going to use unnecessary memory, or you are going to have some functionality issues later. So hope there are no other doubts. Don't worry, even if you have a doubt, just note down your doubts. Tomorrow we'll have a continuation where I will give the introduction of Elasticsearch, where we will see all the Elasticsearch specific features, how we tackle this problem. I noted down some other questions also. I will answer them tomorrow. Thanks a lot.